Hello students, welcome to IMS Academy. In this session, I am going to discuss 10 challenging questions of analog circuits. But I hope you are all ready to do these questions. One by one I will do. If you are getting answer in before my answer, just you can message it and say now. Each and every question is very good. I will start the session now. This is the first question. Anybody can do this question? The Nehru Gopal, hello sir. Good afternoon, good afternoon, good afternoon. This is the first question. Anybody can do this question? A silicon transistor with VB is SAT equal to 0.8 volts, beta DC equal to 100 and VC is SAT equal to 0.2 volts is used in the circuit shown below. What is the minimum value of RC for which the transistor is in saturation? But the problem it is given the transistor is in saturation. If it is in saturation, we need to find out RC value. This RC value is required. How to find? What's the way to find? But you know very well when the transistor will come to the saturation stage. When the supply voltage is given here now, base voltage is going to flow. When the base voltage you are increasing more and more, base voltage also current also increasing more and more. Simultaneously collector current also going to increase. Collector current also increases now. But after some time, what is going to happen now? Once the, yes, Pragya Tiwari, good morning, sir, good morning, good morning. Yes, once the transistor reaches to the saturation state, the voltage across collector to emitter is given as a 0.2 voltage, here given clearly, 0.2 voltage when it reaches to the saturation level. Now, how to find out this RC, we can see now. The current which is passing through this 200K, I wish to take it as a base current. This current I want to take base current. The voltage across base and emitter is given in the problem 0.8 volts. This is 0.8 volts. Collector to emitter voltage is given 0.2 volts. The current which passes through this RC is nothing but the IC. This IC is nothing but IC SAT, you know, IC SAT only that value. Anyhow, when the problem is asking minimum value of RC, minimum only now. Minimum is not given, you think it's so. RC value must be taken greater than or equal to. If it is not given, minimum is given, RC equal to is possible in the problem. Anyhow, in the problem, it is required initially base current. Without base current, I cannot find out RC value. How to find this base current is more important. Base current is calculated by, base current is nothing but the current passing through 200K. Yes, option B, sir. Yes, you are giving the option B. I will check. Yes, exactly correct. Yes, you are very fast, Gopal. Yes, IB is given 5 minus 0.8, 5 minus 0.8 divided by 200K, 200 kilo. This base current will be 21 microamperes possible. 21 microamperes is possible. Once you got the base current, you can determine IC value. IC equal to beta into IB, no doubt. Beta is given in the problem 100. 21 into 10 power minus 6, you will get here now. So finally, the collector current is 2.1 milliampere. 2.1 milliamperes possibles. Then I can determine RC value. RC is nothing but supply voltage minus collector to emitter voltage divided by IC. 10 minus 0.2 divided by 10 volts. Sorry, RC, what now? IC. IC is nothing but the 2.1 milli. And what is RC? The value of RC is 4667 ohms possible now. This is RC value. So, option B is correct in this particular problem. Option B is correct. Yes, exactly. One student gave answer. And I will see how many students can give this answer now. Second question I will give in your hand. By using the diode, I wish to give one question. You please try this. Yes, you try this question. Can you try this question without my help? Anybody can do this question? Anybody can do this question? What is given in this particular problem? For the circuits in the figure below, the value of Vd is dash volts. Assume the diode is ideal. Yes, assume the diode is ideal is not allowed here now, because the value of Vd, voltage across the diode, whenever he asks, assume the diode is ideal, not allowed. It's not ideal diode only now. So possible also now. Non-ideal means what? When it is a forward bias, ideal only also. Sorry, I can put it 100% allowed. If it is unstayed forward bias, you can put ideal only. If it is a reverse bias, possible some voltage drop. Ideal diode is specified means what is the meaning there? Yes, Pragyavat Tripathi. Sir, this is 1 milli or 1 mark or 2 mark. Yeah, these are all, this is a 1 mark question only now. This is just 1 mark given for 1 mark. But how we can find voltage across the diode? In the two cases possible, ideal diode is given, sir, directly I will put voltage across the diode is 0. We can't say like that. Why we can't say, sir? If the diode is forward bias, we can say voltage across the diode is a 0 voltage only now. In case the diode is a reverse bias, some voltage drop is possible. That's why we need to identify the diode is a forward bias or reverse bias. At the time, what you must do, you need to find out the voltage at this point. We need to find voltage at this particular point. As per the Thevenins, we can find this voltage. Thevenins TH1. And Thevenin's voltage here I will find VTH2. And also I can find RT1 and RT2 also. Yes, it gave -2 voltage. Yes, exactly correct, -2 voltage. You are doing very fast, very good Gopal. But here given VTH1 is required, by using the Thevenins directly we can do. Don't take more steps, directly you write. VTH1 is nothing but the voltage across 10K supply voltage into. Whenever the Thevenin's voltage you are finding, this is the open circuit, you know very well. At the time voltage across this 10K is the Thevenin's voltage. How we can find 8 into, I can write 10K by 10 plus 10, 20. It becomes a 4 voltage only now. VTH1 I got as a 8 voltage. We need to find RTH1 also. When the DC source is sorted 10K in parallel, it becomes a 5K only. In the same way, VTH2 is required. VTH2 is nothing but whenever this circuit is an open circuit, this node voltage is required. This node voltage is nothing but voltage across 10K, 4 into 10K by 10 plus 10, 20K I can write here now, 20. It becomes 10 to 2 voltage is possible here now. RTH2 is nothing but these two resistors are in parallel, it becomes a 5K only now. Finally, we are getting this circuit in this way. There is a VTH1 4 volts and resistor RTH1 5K we got here. There is a diode here. The diode I can connect like this. And here I got, I say what now, resistance of 5K here again, and also connected with a 2 voltage only now. Now the diode is a forward bias or reverse bias. It is a reverse bias. Anode voltage is less than the what now, cathode voltage. Diode is reverse bias. If diode is reverse bias, no current will pass. Drop across 5K 0, drop across 5K 0, and voltage across diode equal to 2 minus 4. It becomes a -2 voltage only. This is the solution for this question. Such a way we can tackle this question. And I want to give one more question. You please try this. Yes. This is very fast. You can do this one. From the clamping circuit, one question I gave it now. By using the clamping. Very direct question. Anybody can do. By using the clamping circuit, you can complete this question very fast. Not required any work, very directly you can give. Any student can give. Repeatedly asking question from the clamping, such a type of question in the gate and engineering service and even in the PSUs. That's why I gave this question. The value of VC3, this is nothing but VC3 in given figure, if V in is a 5 sin t volts is. VC3 means this voltage is required. Yes, option A is sir. Yes, very good. Option A is a correct one, 100% correct option A. But in this case, whenever the clamping circuit is given, voltage across the capacitor, first capacitor will be Vm only possible. The rest of capacitors can have voltage of 2 Vm. Whatever the number of capacitors are given, you will have the 2 Vm only now. And I can say here now Vc3 is nothing but, directly you can write, Vc3 is nothing but 2 Vm. 2 into Vm. Vm is nothing but the maximum voltage is given 5. 2 5s, 10 voltage is possible. Yes, 10 voltage Vc3 is correct. Option E is correct in this particular problem. Yes, you followed, I think, now. Minus 5, Vc2, 2, Vc3, 10. Very good, exactly correct. Vc1 is a 5 voltage, Vc2 is a 10 voltage, Vc3 is a 10. Exactly correct. Yes. You had a good preparation, I think, Mr. Gopal. Yes, my name also Gopal, your name also there Gopal. Okay, very good. Yes, we can do the next question here now. Yes, no, was this question. And please start doing this question. Anybody can find this problem? Please start doing this question. But I want to wait for some time. You please tackle this question without my help. Which option is correct in this particular problem? From the current mirror biasing circuits, I selected this question. If you are very perfect in the current mirror biasing circuits, you can do very easily this question. It doesn't take more time. Easily you can tackle this question. Yes, I will start doing this question now. How we can tackle this question? Here it is given here one current mirror. This current and this current will be same. When beta is a very large, beta is infinity is again very large. When beta is very large, I and current passing through this side will be same for this current mirror. This and this is again current mirror. Is a NPN, this is a PNP transistor. In the PNP transistor, this current and this current will be same. Same current this side also. Same, these two will be having the same current only. And this current, if you calculate it, quite okay. This current and this current same only, I said now. How we can find that current? Just we can apply the KVL by selecting the path in this particular direction. I will go by this path. I will go by this path. Apply KVL in this particular path. The selection of the path is selected in this particular way. Easily you can determine the current I. Apply the KVL. Supply voltage equal to, the supply voltage is given here the 10 volts. 10 volts equal to, when you go this side, base to emitter voltage is given 0.7 voltage here. When you go this side, there is no drop. Drop across 10K becomes 10K into I. 10K into I. When you go this side, again some drop, 0.7 here. When you go this side, minus 10 voltage, you can have this side. Yes, you try this value here now. The I can be calculated 10 plus 10, 20 minus 1.4 divided by 10K. By using this way you can complete. 20 minus 1.4, 18.6 I can write. By 10K is given here now, 10K. Now finally the current I is nothing but 1.86 milliamperes of current is passing in this circuit. So which option is correct? Option D is correct in this particular problem. Yes, option D is correct. That way we can get answer now. D is correct. Yes, exactly, you are correct. D only correct here now. Just the current, but to know how to do the problems in the current mirror biasing, I gave this question. One question from the current mirror, one question from the clamping circuit, and also I gave one question from the diode circuits, one from the transistor. I gave it so far. And I wish to give one more good question in your hand. You please try this question. Yes, the question I selected from the feedback amplifier. I hope you can do easily. Anybody can try this question without my help? Just watch what is given in the problem and start doing this question. Yes, I am going to wait for some time. You start doing this question. It is an MSQ question. It is one of the MSQ question. I hope you can do easily. You can have more than one solution here. The voltage gain Ri and R0 with feedback for voltage series feedback having A equal to minus 100, Ri equal to 10 kilo ohm and R0 equal to 20 kilo ohm for feedback factor beta equal to minus 0.1 is asking three questions. Is asking three questions here now. What are those three questions are asked? The first question is the voltage gain. Voltage gain is required. The voltage gain is required after feedback only. AF feedback gain. Voltage gain we need to find after the feedback only. What way we can find the voltage gain? By using the formula A by open loop gain divided by 1 plus A beta. The formula generally we are going to apply. A is given in the problem without feedback. It is given minus 100 here given. Divided by 1 plus A is nothing but the minus 100 here. And beta is given as a minus 0.1, minus 0.1, minus 0.1. But you find what is the feedback gain. Here you will get minus 100 by minus 100 by 100 plus 0.1. It becomes a what? No, 10, 11 is possible. Minus 100 by 11. Minus 100 by 11, I can take it as a minus 9.09, minus 9.09. Yes, this option is a correct value now. Feedback gain we are getting same value. Minus 9.09 is correct value now. And the next one, the type of the feedback it is given is nothing but the what is that type of voltage series feedback here given? This is voltage series feedback. But you know very well, we know very well A and D you say, A and D. D is a none, you say. Yes, we can check otherwise now. It is a voltage series feedback means you know RIF is required. After feedback, RI and R0 after feedback only required. With feedback is given. What is RIF for voltage series feedback? Anybody can give? Anybody? 1 plus A beta into 1 plus A beta into RI we are going to use for voltage series feedback. For voltage series feedback, input impedance will be increased and output impedance will be decreased. Condition we know. So increase means product, decrease means divided only. We know very well. 1 plus A beta, 1 plus A beta I got here now, 11 here now. This is 11 into RI. RI is nothing but the 10K. 10K is given. 10 into 110 kilo ohm we are getting. 110 kilo ohm we are getting. 110 kilo ohm you are getting means B also correct. RIF 110 kilo ohm it is given. So that is also correct now. And we can check RYF is a correct or wrong. I don't have an idea so far now. But in the voltage series feedback amplifier, output impedance will be decreased. ABC, yes, exactly correct, Gopal. That's right only now. Understand now. But I wish to find the RYF. RYF is calculated by R0 by 1 plus A beta. Output impedance will be decreased because of the negative feedback. In the voltage series feedback amplifier, RYF will be decreased only now. So R0 is given in the problem. What is given? 20K. Divided by 1 plus A beta is nothing but 1 plus A beta is nothing but 11 only now. Finally, its value will be 1.82K. It is 1.82K. So C also correct. So what is the solution? A, B, C are correct. Yes, you are correct, Mr. Gopal. And I want to give one more question. Just you practice, you give your answer. I'm waiting for your valuable answer. This is one more good question from the operational amplifier. But I will wait for some time. You start doing this question. I want to wait for some time. It takes some time. It is a 2 marks question on the gauge. The gauge you can expect 2 marks questions, such type questions. Such type questions you can expect for 2 marks. Anybody can do this question? But I want to wait for some time. What V naught you can get from this problem? What V naught you can get? Can you find V naught from the given problem? It's a very good question. It's going to take some time. So how to do this question means, please watch it now. Thereby required the output voltage of the following circuit announcing ideal behavior is dash volts. What is given? The given operational amplifiers are ideal, strictly given in the problem. Ideal behavior specified in the problem itself. Is asking to find the output voltage. What is V naught? Thereby required V naught value. For ideal op amp, you know V plus and V minus same. This voltage is 1 volt, no doubt. That voltage is a 1 voltage only now. Supply voltage is given 1 voltage. Initially, I wish to find this voltage V plus. The same voltage will be maintained here also. How to find? Sir, weights are, yes, okay, I will wait, no problem, no problem. Okay, I will wait for some time. Waiting for your answer. Getting anybody? You need to do somewhat fast. Yes, you start doing there now. Here now I will start doing here now. If you got answer, you message, no problem. As these two voltages are same, this voltage I wish to take it as a V1. This voltage is nothing but the V naught, you know very well. The current is going to flow because of the V naught. The current will pass in this particular direction and will try to divert this side. No current is going to pass across this positive terminal. Why doesn't pass? Yes, Gopal, getting the 4 volts. Yes, exactly correct. You are perfect. 100% perfect. What you did is right. Yes, 4 voltage is correct. Yes, I will find what is V1 here now. This V1 is nothing but at this side no current is passing, because input impedance of operational amplifier is very infinite, you know. That is why the total current is going to divert in this particular direction only now. The voltage across this 1K is nothing but, according to voltage division formula, I can write V naught into 1K by 1 by kilo cancel now. 1 plus 7, 8. V naught by 8 I got. Yes, this node voltage is to be taken as a V naught by 8, no doubt. V naught by 8 only now. Same V naught by 8 you can maintain here now. I am writing clearly now. This voltage also V naught by 8 I said. This voltage is a 1 voltage. This voltage I wish to take it as a, already V1 is over. This voltage I want to take V2 only now. By using the nodal analysis, I can determine what is V2. This current plus this current equal to 0. It doesn't flow any current across this negative terminal. The reason behind it is the operational amplifier is ideal. In ideal case, infinite resistance you can find. That's why as per the nodal analysis, this current is V naught by 8 minus 1, V naught by 8 minus 1 divided by 1K, all are in kilo ohms 1. plus this current is V naught by 8, V naught by 8 minus V2 divided by 2K, that equal to 0 I can put here now. 2K, kilo cancel here now, I think. Kilo will be cancelled. And I want to get what is V2 here now. Why we are applying their nodal means to find out the V2 value. You find V2 in terms of V naught. On simplification, V2 you will get like this now. 3 V naught minus 16, take LCM, you will get this. 3 V naught minus 16 by 8 you will get. That much voltage you can get. Once you are getting the V2, you can try for V naught. This node I selected and I want to apply nodal this side and this side. These two currents equal to 0. What current is going to flow this side? 1 minus V2, V2 value we know. As per nodal 1 minus 3 V naught minus 16 divided by 8 divided by 4 plus this current is 1 minus V naught, 1 minus V naught divided by 8. This is equal to 0 I can write now. So we got an equation in terms of V naught. We don't have any other variables, you know. Easily you can determine V naught. Use calculator and find what is V naught. If you are using the calculator, V naught is 4 volts possible. This value will be 4 volts, we know. Yes, that simplification work you can do easily now. Yes, what you did is a correct, Mr. Gopal. V naught is 4 volts, no doubt. And you please try one more question I will give in your hand. I will give you time. You start doing this question. You please try this question without my help. Yes. Can you get answer for this question? What's given in this question? For the figure shown, the op amps are ideal and voltage gain AV equal to V naught by VI is 100. And also given here now, the R1 equal to 1K and R2 equal to 2K, R4 equal to 1K, then the value of R2 is dash mega ohms. Thereby asking to find R3 value, it must be required in mega ohms. Any student can do this question? Required R3 value in mega ohms. What do you say, Mr. Gopal? Shall I wait or shall I start doing this question? Shall I wait or shall I do? Anybody is doing? Any student is trying this question or not? You please tell me. Shall I do? Shall I do or shall I wait? Please tell me. Yes, I will start doing this question now. But in this particular problem, you know, this is the operational amplifier, this is one more operational amplifier you got. This is connected, this positive terminal is connected with 0 voltage here. It is connected with 0. Yes, Gopal says 0.1. No, not 0.1. Please cross check once again. Please cross check once again. It is not 0.1. Mega ohms required. What mega ohm resistor is to be connected in this particular circuit? You try to get it. 0.1 is not correct. It is incorrect. You please try. Yes, I will do, please watch. This is connected to the ground 0 voltage, even this node voltage also 0 voltage possible. If it is 0 voltage, this is also same 0 voltage only. This node voltage, you know, same V naught, output voltage V naught only possible. But this node voltage is unknown. I wish to take that as a V1 or Vx we can put otherwise. Already Vi is there now. Vi and V1 will be confusing. I selected that as a Vx only now. So which way we can tackle this question? Initially, I selected this node voltage. By selecting this node voltage, I want to find Vx at first. By selecting this, our aim is to find the R3 only now. But a V naught by Va is given 100 here now. By using this node voltage node, I want to find the Vx value. How we can find this? This current plus this current equal to 0, no doubt. It doesn't flow this side any current. According to nodal analysis, we can find this current 0 minus Vx, 0 minus Vx divide 0 minus Vx by R4 plus this current is 0 minus V naught, 0 minus V naught divided by R2, R3 is given, divided by R3. This is equal to 0. This is equal to 0 only now. But I wish to find what is Vx from here. So here I am getting the Vx by R4 equal to Vx by R4 equal to minus V naught by R3. And finally, Vx is nothing but minus V naught into R4 by R3 I can get. This is Vx value. Are you getting the same? This is Vx value we are getting. But why we need to find this Vx means, finally I wish to get one equation in terms of V naught and Vi. I wish to get final equation in terms of V1, Vi and V naught only now. Vi and V naught if you got, yes, 0.05 mega ohm. 0.05 mega ohm is 100% perfect, Mr. Gopal. What you did is right, exactly correct. Yes, in this case, this node voltage we know very well. Positive terminal is given 0 voltage, even this voltage also same 0 voltage only. I can apply nodal analysis again. This current plus this current equal 0. It doesn't flow any current in this particular direction. How we can measure the current in this direction? 0 minus Vi, 0 minus Vi divided by Ri, R1 plus this current is 0 minus Vx, 0 minus Vx minus minus plus V naught into R4 by R3. This is equal to 0. I can take it now. So Vi by R1 equal to Vi by R1 equal to V0 R4 by R3 I can write. But I want V naught by Vi. That is the voltage gain. V naught by Vi is nothing but what I can write, R3 by R1 R4. R1 R4 you can write now. So V naught by Vi equal to R3 by R1 R4 only now. So we know very well what is V naught by Vi. V naught by Vi is given in the problem 100, clearly given, 100 directly given, 100 is given. So 100 equal to R3 is required here, R1 R4. R1 is given 1K, R1 is given 100, R4 is given here 1K, 14 is given here. R3, finally you are going to get R3 in kilo ohms only now. What value is possible here? Are you getting like this now? But R3 into one more value is there now, one more is there now here now. The V0 by Vi equal to V0 by R2, R3 by only now. R2 is lacking at somewhere. You check it now. Somewhere it is lacking R2. Vx by 0 minus, just let me 0 minus Vx by R4, no doubts. That is okay. And here now 0 minus Vx, 0 minus Vi, 0 minus Vi by R1 plus 0 minus Vx by R2. This R2 I neglected. By R2 is there. Yes, correct here. Because 1k kilo k square it is going to become now. Yes, I am your classroom students are very good, very good, very good. Yes, here I am getting the R2 here now. Is it now? One more R2 is there now that I have forgotten to take only now. V0 R4 by R3 is there here now. Into R2 also is there now, no doubt. And R3 into R2 by, yes. But R2 into R2 is given in the problem. How much 2k is given here now? And finally, if you simplified, R3 value will be 0.05 mega ohms. 0.05 mega. That much value possible. Yes, you are saying my classroom student. The where is it in Vijayawada or otherwise Bangalore? You are from Bangalore or Vijayawada? Mr. Gopal. May I know that? I am your classroom student, you said now. You are from where? Yes, I wish to give one more question in your hand. You please try this question. Yes, I wish to give one more question. Yes, you please try this question. You please tackle this question without my help. Anybody can find solution for this? Batch EE. No online class students are. Okay, batch. Okay, very good, very good, very good now. Because we said the classroom student means I got offline. Okay, no problem. Now it is online student. Very good, very good. Yes, will you get answer for this question? Will you get answer for this question without my help? Anybody? But I will wait for some time. You please tackle this question. I want to wait for some time. You please tackle this question. But thereby required resistance R. Thereby required resistance R. You try to find R value from the given problem. You try to find resistance R from the given problem. What is the value of R from the given problem? But the problem is asking to calculate the value of R for which the output of the circuit becomes 0 voltage, R equal to dash kilo ohms. Is asking to find the resistance R in kilo ohms. The output voltage is given 0 voltage. The output voltage is given 0 voltage. That means when V0 equal to 0 voltage, you find out the value of R. This is the question. That is the question only now. But in this problem, what you can do, because of the connection of these two voltages, it's going to flow current of I1 here. This current is nothing but the I2 value. But I want to say 2.857 kilo ohms, 2.857 kilo ohms, very perfect. Mr. Gopal, you are doing very well now. Your practice is very good, I think, now. Good, good. Yes, anyhow, initially we need to know this node voltage. That node voltage, I want to take it as a V. This node voltage I want to take it as a V. If this voltage is V, even this voltage also same V, no doubt. After getting the value of V, we can find this I1 and I2. This I1 and I2 will flow this side. This current can be taken as a I3 value only now. We know very well I1 plus I2 equal to I3 only now. I1 plus this current equal to this current only now. This side no current will pass because of the ideal op-amp. Infinite resistance it can have, you know very well. But in this case, initially we need to find what is V. The V is nothing but the voltage across this R, voltage across resistance R. By means of applying voltage divider formula, we can determine voltage V, because the total current is going to pass in this particular direction only now. The same current is passing through the all the resistors, we can apply voltage divider formula. V equal to 6 into supply voltage into R by 6 into R by 10K plus R. I can write 10K plus R. By using the voltage divider formula, I got this voltage V. So this voltage is same. So I1, I2 equal to I3 we know very well. I1 plus I2 equal to I3, no doubt. Addition of these two currents equal to, we can take it as I3. I1 is nothing but the current across 10K, 2 minus V by 10K, 2 minus V. 2 minus V is nothing but 6R by 10K plus R. I can put divided by 10K, I can write, plus I2 is nothing but current passing through 10K, 2 minus V. 2 minus V is nothing but 6R by 10K plus R divided by 10K, I can get here now. This is equal to I3. I3 is nothing but the V minus 0 by 10K, I can write now. I can cancel this K. Throughout the equation, I can cancel this K only now. 10K, 10K, I can cancel directly. The finally what I am getting 2 plus 2 is nothing but the 4. Here I am getting 10K plus R, but the minus 6R minus 12R by 10K plus R I am getting here now. 10K plus R. This side I am getting V. That side I am getting, but V we are getting here now. This side is nothing but the V minus 0. V equal to, we know very well. What is V? 6R. We can write now best. We can put here now. That V value we know very well. That V is nothing but, that V equal to 6R by 10K plus R. But I want to take LCM 40K here plus 4R here minus 12R, that equal to 6R I can put now. That is a 6R I can get now. But what is the total R we are getting here now? 4R minus what total R it comes here now finally? What R you are getting finally? But 40K and 40K we are getting constant. 40K we are getting here now. 4R is there now. 40K. 4R minus 8R it comes. 14R is possible, I think now. 14R is possible. 14R. Am I correct? What R you are getting? Am I correct or not now? You will. The 10 and 10, yes, 5 ohms, that also possible. That way also possible now. That way also it is acceptable. 100% correct. That way also we can tackle. That way also allowed. Yes, here we are getting the. Yes, it is a finally R equal to what I can write now, 40K by 14. The finally this value will be 2.857, 2.857K. That is simple way only now. Yes, what you did is a correct only now. The 10 ohms and 10 is a, yes, they are all in parallel, correct only now, acceptable. Yes, I did what now, just one systematic conventional approach I applied only now. Any way you can tackle now, understand. That way we can tackle. And I wish to give one more question in your hand. You please try to tackle this question without my help. This problem you complete. It is one of the MSQ question I want to give in your hand. This is one more MSQ question. Can you do this without my help? Can you do this without my help? This is the 9th problem. The 10th problem I will give in your hand only now. You need to complete. If you are getting answer, very good. Please tackle this question. It is one of the MSQ question. I will see how many students can tackle this problem. Anybody? Can you complete this question? But here given 3 diodes, they were all connected in parallel. One is made up of silicon, one more is a germanium, third one is nothing but the gallium arsenide. But here all 3 diodes are going to be on state or any one of the diode is on. But all the diodes are connected with same supply voltage, 5 volts only now. But the drop across each diode is not same. It is not specified in the problem. They are all ideal diodes, not given in the problem. So the diode, the germanium can have some voltage drop across. This silicon is a different voltage drop. Gallium arsenide is different value. So once we know the voltage drop across each and every one of the diode, we can tackle this question easily. Which diode is on depends upon the voltage drop which can have a less voltage drop only now. The diode which can have a low voltage drop can be on state. The remaining diodes will be off state only possible now. But you know very well the drop across the silicon is possible 0.7 voltage. The voltage drop across silicon is 0.7 voltage. Sir, what is the threshold voltage of gallium arsenide? Yes, that I am giving now. That only I am giving here now. I am giving only one germanium will be in forward bias. Yes, that is why I am giving now. Yes. Sampath Babu, only germanium. Very good, very good. Germanium only. Because you need to know the gallium arsenide voltage drop also. But the germanium can have 0.3 voltage, you know very well. 0.3 voltage possible here now. But a gallium arsenide can have 1.2 voltage drop. This is the threshold voltage. The voltage drop across the gallium arsenide is 1.2 voltage only now. But from the given data, you can understand clearly. What you can understand, the which diode is on means which diode can have the voltage drop of low means germanium is with low voltage drop. So very fast it is going to operate. Very fast it is going to operate because the drop across the diode is a very less. The diode, the solution I can write here now, the diode which is with low voltage drop is on state only possible. The rest of diodes will be off state only now. So here this is off, this is off, this is on. On means this is on, drop is 0.3 only now. It is on with a drop 0.3. I can find the, what now, the which diode, but what is asking the problem? Find V0 is asking. V0 is nothing but, I can write directly, V0 is nothing but 5 minus 0.3. 5 minus 0.3, that is a 4.7 voltage is possible. What voltage I can get at this particular point, sir? 5 minus 0.3, 4.3 volt is a V naught is possible. What about the current I, sir? Current I is nothing but current passing through 2.2 K. But this voltage we know node voltage V naught by 2.2 K, if it is taken, you will get directly I. So I can say the current I is nothing but V naught by 2.2 K. 2.2 K. V naught is 4.7 volts divided by 2.2 K. And finally, the current I is 2.13 milliamperes. 2.13 milliamperes of current is passing in this particular circuit only, you can say. That is current I. So what those options are correct here now? The V naught is 4.7 we are getting. B is correct here. And also 2.13 milliamperes means C also correct. B and C are correct in this particular problem. I hope you followed. The last problem I will not touch. Just I want to give in the hands of the students. That question is from the MOSFET. You make an effort. If you are getting, very good. Otherwise, you start trying this question. 10th question must be given in the hands of the students, I think. So you can try without my help this question. This is the question you can do without my help. Without my help. I am giving the time you try to tackle this question. If you are not getting, just you practice it. But if anybody is getting answer, they can message. I can understand whether you are in a position to do this question or not. Just give your answer for this question. Just you give your answer for this question. Anybody can give answer for this question? Is asking to measure or not? Is asking to measure or not? The MOSFET is given, transconductance is given, and also he is given RS and R naught how to find. By using this small signal analysis, you can do only now. Option D is correct. D is not correct. It is not 100. It is not 100. Can you try? Draw the circuit and find yourself. Just here I will apply the direct formula. You try small signal analysis to apply, you will get only now. B also not correct. Generally, they are going to use the R naught is calculated by 1 by GM into 1 by RS by using the small signal analysis. By using the small signal analysis. There you substitute values 1 by 3 into 10 power minus 3 plus RS is a 3000 here. 3000 is to be taken here now. 1 by RS, sorry, 1 by RS, 1 by 300 here. I am writing again. Just apply the what now? Small signal analysis you will get now. Small signal analysis you will get now. Here a GM is given 3 into, sorry, that's given 3 into 10 power minus 3. 1 by RS, RS is nothing but 3000. If you are using the calculator, R naught comes as 300 ohms only now, 300 ohms. But you apply the what now? Small signal analysis, you are going to get answer only now. I hope you followed so far all 10 questions I did now. Okay then, bye. Thank you all.